Okay, from the 240 become 20. Okay, another Y. Suppose the question, you know, like this one transformer, this one's a Y. Y actually they want to convert AC become DC. Okay, that one should be diode last. So from here, this one should be the transformer. So from here, they just name the component for the box X. So when we see this one is 240, we want to drop until 20. So we give the full name is a specific a little bit. There's a step down transformer. Okay, step down transformer. Okay, then we continue to the question. State the physics concept, okay, which explain how the component box X is work. So that means the transformer we're using what concept? Okay, the concept is you need to generate the electricity. That means you need to cut the magnetic flux. Then finally the secondary circuit that can get the current. So that one is come from the electromagnetic induction. Okay, this one is a concept for the transformer. Okay, then we go to the 3, B already. The function for the component X, lower 240 to 20. Okay, now they want you to find out the number of turn for the primary coil, 960. Okay, this one is a primary coil. Now they want to find out the number of turn for the secondary coil. Okay, what we get the info? We get the info is this one. 240 is primary volt. Then the number of turn for the primary is 960. Okay, after that, we know they're connected to the handphone. The handphone is 20 volt. Then we need to find is the secondary number of turn. Okay, so I'm going to ask the student, give me the answer. Ryan, have you do it?
Yes.
Okay, what's the answer for NS?
80 tons.
80 turns. Okay, we show the calculation. Okay, this is the formula for the transformer. We need to use it. Okay, after that, we just put in. Okay, NP is 960, then 20 over 240, then we find NS. So NS is a 80 turns. Okay, you must answer in unit. There's a turns. Okay, just apply the transformer formula. Okay, then we go to the 2 marks. This one question is 2 marks. That means you need to show the calculation, not only for answer. Okay, then we go to the C. Okay, the efficiency of the component of the box is 80%. Okay, so you need to count about the efficiency. So calculate the input current when the output power is a 65. So they provided the output power. So input power we don't know. But from here, the question never provide any power. So we just got voltage, okay, and also the number of turn. Okay, but from here they say I want input current. So you must relate the power and also the current. P equal VI. So this one is the input. So that means you need to find the power input equal voltage input and current input. So we just put the info. Okay, just now we find 80 turns ready for the secondary coil. So from here, we need to find the efficiency. So I show the formula for efficiency. This one is the efficiency. PO over PI. Remember, always the output at the top because your answer cannot more than 100%. So PO over PI multiply 100%. PO means secondary coil. PI means the primary coil. Okay. So from here, ask about Lao Ling Han. Have you do it?
Yes.
Okay, what's the answer for the current input?
0.34 ampere.
0.34 ampere. Okay, we're going to check. Okay, we are putting all the things. So, but the bottom, you need to remember PI. From here, we cannot straightforward using PI. PI, you cannot find the current. So we separate the formula for power input. There's a voltage input and current input. So that means I want to find is the IP. IP is a primary, that means the current input. So I just get it 0.34 ampere. Okay, so when you just apply the formula is correct, that means there's no problem. And also remember to write the info. Info is important for you to guide you to do the calculations. Okay, then we go to the next part, question number 2. Okay, identical copper rod placed on the copper wire, okay, in the magnetic field. So you can see two diagram here. Okay, this one is a copper rod that can move one. Okay, so now you can observe what is the differences. Normally the question give you two diagrams, that means the question is call you to compare. Okay, for the physics structure question, at least got two questions is a comparison. So first one is in the structure question, section A. I mean, just like this one, they got space, let you to write. Okay, another question is a section B. That means is together, they join together one, maybe 5 marks. They join together, then they call you to do a comparison. That one is another comparison question. So comparison, I think there's no problem for you, is it? Just remember, don't write the symbol. Okay, you need to write bigger or smaller and full sentence. Okay, so from here you see the diagram, what's the differences before we start go to do the question. Okay, first one, I find it the battery is a different. Okay, 2.2, the battery is more. Okay, number 2, I find the distance of the copper rod to move. Okay, 2.2, the copper rod move further. Okay, from the ori is the same. After that, they move further. Okay, number 3, I find it the ammeter reading is different. Ammeter reading deflected for the 2.2, the angle is bigger. Okay, so from here we find it, this one is the differences from the diagram 2.2. That means 2.2, they produce more current. When they just produce more current, that means the force increase. Then the copper can go further. Then the ammeter to show you already, the current flows through the circuit must be higher. Okay, after we analyzing the diagram, that means we can start to do the comparison. So what is the meaning of the magnetic field? Okay, magnetic field means what? So you must give the definition for the magnetic field. Okay, so that means the magnetic field means region. You must start the word of region. Okay, because field is one of the region. Okay, a region where the magnetic substance, or you say material, okay, the experiences must have the word magnetic force. Okay, you can say substance, you can say magnetic material that experiences the magnetic force. So this one we call it as a magnetic field. Okay, so B. Okay, B start comparison. So we compare the number of the dry cell. So you see the number of the dry cell. So how to start the sentence? You just copy from the question. Number of the dry cell used in diagram 2.2 is more. Okay, then finish. You no need to more than 2.1. You just more enough. Okay, so that means don't write this. Okay, because sometimes every year they will change about the scheme answer marks. This year they can accept the symbol. Next year they cannot accept. Depend the question. If the question very easy, that means they want to marking about straight. So that means 2.2 bigger than 2.1 like this, they don't want to accept. Okay, so better for you, you want to save, we write in full sentence. Full sentence, sure they will accept one. Okay, we just write number of the dry cell in the diagram 2.2 is more than 2.1, or you just more in 2.2 also can. Okay, then we do the next comparison. Angle diffraction of the ammeter. Okay, remember the ammeter always deflected from the zero. Zero is the left hand side. Okay, then they diffracted to the right hand side. So from here, you also need to start with the angle of deflection of ammeter pointer. In diagram 2.2 is greater. Okay, is larger than 2.1. Okay, or you say larger than finish. Okay, also can. Don't write symbol. Okay, the next one, compare the final positions. Final position, then you just start with the final position of the copper rod in the diagram 2.2, move further. Okay, move further, then we finish. So from here, copper rod in diagram 2.2, they move further than 2.1. Also can. Okay, just important, don't write the symbol. Okay, now we need to state the physical quantity that caused the rod to move. Who caused the rod to move? Okay, the physical quantity means what we learn about the physics, something that can measure. Okay, so this question I want to ask about the Jaya.
Current.
Current make it to move. No,
Then
then think about that lah. One more. Fleming left hand rule. We got magnet, we got current, and one more.
force.
Got force, baru can move. Current, how to make it move? Current make the charge to move only. Current cannot make the copper rod to move one. So that means the answer must be force. Force to make it to move. That's why you're using Fleming left-hand rule. We got magnet, then we got current flow through the rod, then finally they produce the force. Okay, so this one should be the answer. Okay, we continue. After do the comparison, the next one sure is a relationship. Okay, the question will ask about the relationship. At least 3 compare, 2 relate. So already is 5 marks. Okay, so from here they call you to relate the number of the dry cell and also the magnitude of the electric current. Magnitude means value. So they want you to compare the dry cell and also the ammeter reading. So from here actually is what? So we straightforward answer MV first, then later is RV. So from here the MV should be dry cell. So you just when the number of the dry cell increase, the magnitude of the electric current also increase. Okay, you want to mention about directly proportional is okay, but must full sentence. Don't just put directly proportional. Okay, you just say number of the dry cell directly proportional with the magnitude of the electric current flow. Okay, that one is a full sentence. So from here we just write, as the number of the dry cell increase, the greater the magnitude of the electric current flow. Okay, now second relationship. Magnitude of the current flow and the magnitude of the physical quantity just now you stated. So just now you state there's a force, is it? So that means now the MV is what? Now the MV is a magnitude current. Okay, responding variable now is a force. So we mentioned about the current first. So that means when the magnitude of the current is, so the magnitude of the force, don't say magnitude of the physical quantity state into C. We straightforward say force already. So the magnitude of the force also increase. Okay, the greater magnitude of the electric current flow, the magnitude of the force increase. We continue with E. Name the rule to use to determine the direction of the movement of the upper rod. How you know they want to go up, go in cannot. So we're using what rule? Calvin Yee?
Fleming left-hand rule.
Yeah, we're using Fleming left-hand rule. When you see got magnet, sure it's a Fleming already. Okay, if no magnet, just like the current moving, that one is a right-hand grip rule. Okay, then you see got current or no current. If got current provided, that one is a left hand. No current provided but got magnet, that one is a right hand. Okay, Fleming right hand rule. Okay, now we need to state another one way that can move the rod further. How to make the rod go further? Okay, any suggestion from here? Si Kajing?
Yeah.
Okay, can you tell me what is another factor to make the rod can go further? Okay, you refer the diagram. Which one you want to add to make it to go further?
Increase the number of battery.
Okay, you can increase the number of the battery, but this one already show in the diagram because they give the differences of battery. So got another?
The magnet.
Yeah, you can change the magnet, become stronger, or you add the magnet, make the magnet, the strength become stronger. So from here, the current actually they do not accept already because the two diagram, they already changes about the battery. So from here, the answer must be increase the strength of the magnet. Or you say you increase the bar magnet, also can. Okay, important about the magnet. Okay, so from here to 1, 2 finish already. So number 3, 3.1 show, and also 3.2, they show about the deflection of the galvanometer. You see, again, 2 question comparison. Okay, a bar of the magnet, they are pushed into the 2 identical solenoid. So we see what's the differences before we go to answer. First one, number of turn, I think almost the same lah. Okay, you go to count lah. Okay, almost the same. Then we saw it, the galvanometer. Galvanometer, remember, they start from the center. Okay, the 0 is at the center, then they go to deflected. So I find it 3.1, that deflected with small anchor. 3.2, the anchor is bigger. Okay, then we're going to see what's the difference some more. Magnet. This one using 2 bar of the magnet, they want to move in. This one only 1 bar. Okay, I find it got 2 differences lah. Okay, now we go to answer. Okay, you need to underline the correct answer in the bracket to complete the answer below. So the method of the producing electricity without the electrical supply. So this one using what concept? So from here, sure is a electromagnetic induction. Okay, using the motion produce the current. Okay, so we now do the comparison. Okay, state the magnetic pole at the end B when the bar magnet are pushed into the solenoid. That means you want to move in. So they ask you, what is the polarity of the B now? Okay, we ask about Chu Yishan. What's the answer for B?
North.
Okay, that is a north pole because we follow the Lenz's law. You want to in, I don't let you to in. So when the N just want to in, so I don't let you to in means you need to repel. Repel means this one must be the north pole. Okay, now we need to compare about number of the magnet. So number of the magnet, when you use your eye to see, then you already understand. So we just answer. Number of the bar magnet in diagram 3.2 more than 3.1. Okay, remember, don't mention 3.2 got 2 bar, 3.1 got 1 bar. This one is wrong. This one is state, not compare. Compare means you need to see which one bigger, which one smaller. So we just answer 3.2 is more than 3.1. Okay, using the full sentence. Okay, then the next one, comparison, anchor deflection of the galvanometer. So anchor deflection for the galvanometer, 3.2 is big anchor compared to 3.1. Okay, number 3, compare the number of turn of the solenoid. So you go to count lah. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Also same. So you just answer both number of turn is the same. Okay, you just write equal, then finish. Okay, so this one is a 3 comparison. Okay, next, we're going to see is it relationship or not. Okay, relationship. So relationship between the number of the bar magnet and the strength of the magnetic field. So bar magnet should be MV, strength should be responding. So from here, we just mentioned when the number of the bar magnet increase, the strength of the magnetic field also increase. So we just answer. Okay. The next one, they say about the strength of the magnetic field and anchor deflection. So normally we mention about the strength first lah, because the strength to cause got current. So finally, the strength of the magnetic field increase, the anchor deflection of the galvanometer also increase. So just like this. Don't tell me the question like this, you don't know how to answer. Okay, now, name the physics law involved in D2. The question already specific. They want D2. If the question never mentioned D2, they just say, name the physics law involved in the diagram. Your answer must be Lenz's law. Because Lenz's law is talking about the magnet want to push in. But now, no. The question, they say, the strength and also anchor. So this one is what physics law. So we go to ask Lin Jirong. Okay, what's the answer for E? Name the physics law involved.
Lenz's law.
Just now I say not Lenz's law. If they say refer diagram, there's a Lenz's law, but they say refer D2. D2 is talking about a factor one. Factor is what law?
Faraday laws.
Yeah, Faraday law. Faraday law is talking about a factor. Okay? If the question never mentioned D2, actually you can answer about the Lenz's law. But it said D2. D2 already is a comparison. So that means there's a Faraday law. Okay? State another one way that can increase the angle of deflection of the galvanometer. So that means for this one situation, you cannot mention about the magnet lah, because the diagram already show you 2 bar of the magnet. So you need to think another one. How to make it become the deflection is more. Okay? So we go to ask about the Sharon. Sharon, what's the answer for F?
Increase the number of magnet.
Cannot already because 2 diagram already show about the magnet.
Increase the strength of magnet.
Increase the strength means you increase the magnet. Loh. Another way?
Number of turns.
Okay, you can say number of turns. Okay, you can say number of turns. Okay, another one, you can say the movement. Okay, you can move faster. Increase the relative motion. You also will increase the angle of deflections. Okay, magnet we just ignore because the diagram already show. So from here you can say increase the number of turn, or you can say increase the motion of the magnet. Okay, or you say relative motion when the magnet just put in the solenoid. Okay, so this one is a factor how to make the current produced is higher. Okay, we go to number 4. Okay, state the physics concept they use to produce the voltage. So this one question don't know how many times they asked already. So the electromagnetic induction. Okay, when they just ask about the transformer. Okay, and then we go and see this one transformer, they never tell you the output is how many. They give you W to X is 200 turns. X to Y is 300 turns. And the Y to Z, 500 turns. Okay, then the input sure 600 turns. Okay, but the output we don't know. Okay, let's see the question by the one. Okay, state the 2 pair of the output terminal that can be used when the transformer is used to step up the voltage. I want step up. So that means you must more than 600 lah. You want to step up, is it? Esther?
Yes, teacher.
Which one is a step up voltage?
Step up.
Which pair? W go until? You see, W go to X only 200. So your W must go until? You see, W go to Y. That means 200 plus 300. But still not yet over 600, is it? So W must go until?
Z.
Must go to the Z. This one is the first pair. Okay, second pair, maybe you don't want to start from W. You can start from the X. X go until?
Y.
Y. X go Y only 300.
Or X go to Z.
X go to Z already is 800. So that one is a step up voltage. Okay, so this one is another example for transformer. They don't want to let you to do the calculation. They just show you all the turns. Then you need to find out which one go to which one is until what, how many turns. Okay, now which pair of the output will give the largest output voltage? So just now you give two set already, is it? Now they want to compare. W to Z is largest or X to Z is the largest. So W to Z actually should be the largest lah, because 200 plus 300 plus 500. Okay, just now only X to Z is 800. So that means the choose must be WZ. Already is 1000 turns. Okay, then we go to the next part. Okay, D. They show you about the generator. Okay, this one is no current one. That means you need to move. You need to rotate until they produce the current. Okay, so this one is an alternating current. How I know there's an alternating? Because they got slip rings. They got 2 slip rings. If there's a direct current, they're never using slip ring. They're using commutator. Okay, so from here, they say the table, they show about the 3 alternating current generator, PQR. Okay, first one, they say the number of turn. Number 2, they say about the permanent magnet. This one, N and also the S. They show you the shape. Which one shape you want? Okay, now we see the question, what they need first. Okay, they say about which one is suitable. Alternating generator, they can produce more current. I want more current. Number 2, the bulb must be brighter. Okay, so this one question is normally is a section A, the last question. Before go to essay, you see got some part let you to answer the reason. They almost same like the essay. Essay just never provide the space. This one got provide the space. Okay, so from here, number of the turn, sure you need more, is it? Remember, don't say the number. Don't say I want 10,000. I want 8,700. No, don't mention the number. Just say you want more number of turns. Okay, so we just answer more number of turns, then must give the reason. More number of turns means when they're just cutting. When the flux just cutting, they can produce more. Okay, so that means we just answer increase the rate of cutting magnetic flux. Okay, when you just say the number of turn is more, that means the cutting flux should be more frequently. They cut more about the number of turn flux. Okay, then after that, the shape. Normally the shape we need the curved one. Okay, curved one you find it more concentrate. Okay, the flux at the center is more concentrate compared to the flat one. So this one we got one special name. What means of the concentrate? We call it as a radial. Okay, we're using the curve shape to produce a radial magnetic field. That means they concentrate at the middle. Okay, just like the ammeter, we draw there's a curve. Okay, I go to draw what means of the curve. Okay, they just like this one. Curve. Then the magnet like this curve. Okay, another side also curve. So that means all the field will be concentrate at the middle. So they go cross like this. That means like this. That means they never cross each other. Just they're very focused at the middle. This one we call radial magnetic field. So normally we need is a curve shape. That means curve shape that cover all the magnetic field at the center. Okay, do not lose to the surroundings. Okay, so this is one of the example for the magnet shape. Okay, then we go to the next part. I'm going to change first. Okay, the next part, that means based on 4C1 and 2, you need to choose the most suitable. Okay, to choose the most suitable. Not related, we just go to cross. Okay, I want more one. So this one is not related, we go to cross. Okay, I want the curve one. So the best one must be the Q. So this one is different with the essay. We no need to explain. Straightforward, choose, then enough. No need to say, oh, because, no need. Okay, so this one just one of the things to guide you before you go to essay. So the answer, general Q. Then finish. Okay, then we go through to the number 5. Okay, they show about DC motor. How I know DC? You see commutator. Okay, then got battery or not? Got battery. Got battery means Fleming left hand. Okay, they rotate from the magnetic field. Okay, again the question, what means of magnetic field? Okay, magnetic field means a region where the magnetic substance experience magnetic force. Okay, so the next one, drawing. Make sure you know how to draw. Show about the cross-sectional view of the coil and magnetic DC. So this one, dot means what? Dot is come to you. X means far away from you. So when you just pour using your Fleming left hand, this one, the force must be up. Okay, the force is up. That means the bottom curve. Okay, you show your left hand. This one, the force must be up. Okay, this force must be come down. When up means what? The curve. This one you have more space. So this one is smaller. This one you go here. So this one curve some more. Okay, don't cross. After that, you continue to draw. Okay, so then finish. Then the rest you just draw the normal. Okay, so that means the force is go up. This one is force. This one is a force. Okay, so this one we call drawing. Okay, make sure you know you're using a Fleming. Okay, I show you the actual answer. Okay, this one should be the answer. Okay, I erase my answer lah because you cannot see already. Okay, so you see bottom is a curve, then this one up is a curve. Then you draw the arrow lah. Last part, you must draw the arrow from the north go to south. Then the fourth one is a up, another one should be down. Okay, after drawing, we can see the modification you need to done to make the motor turn faster. Turn faster, you must think about your Fleming left hand. You got 3 of the finger, is it? How to make it turn faster? Turn faster means the F. You want to produce the F is a bigger. So you left 2 finger. 2 finger is what? First, magnet law. You make the magnet become stronger law. Number 2 is should be current. Current, that means you increase the battery. Okay, so from here, first one, they ask you about number of the battery, then you answer increase the number of battery. Okay, reason why you increase the battery, because more current. Okay, more current can flow through the circuit. Okay, this one is why I increase the current. Okay, number 2, sure is a battery. Okay, coin, they ask about coin first. Okay, number of the coin must more. Okay, increase the number of the coin. The reason is when I increase the number of the coin, then the flux cutting should be higher. So I just answer increase the rate of cutting magnetic flux. Okay, shape, we're using curve law. Just now show you already curve shape to produce a rather magnetic field. Okay, if they ask about number of battery, no, this one not about number of battery. They ask you about the strength of the battery, strength of the magnet. So you say increase the strength of the magnet. Okay, then after that, when it just cutting is also increase the rate of the cutting magnetic flux. So from here, actually they crash already. So they never ask you about the magnet. They ask you the shape of the magnet. So you say another reason. There's a rather magnetic field. Okay, so we go to the next. Okay, this one is a question. 10.1, they show about the transformer. Okay, they got bulb. Bulb is the output, 12 volt, 24 watts connected to the output. Efficiency, they provided 90%. Okay, so now you show the transformer first. I sure there's a step down because the wire, you see the number of turn. Okay, different. Okay, now you need to explain the working of the principle. 4 marks. How the transformer to work until the bulb can be light up. First one, you must mention input. Input is an alternating current. Okay, when the alternating current input just put in, that means they produce the current should be various magnitude and also direction. Okay, then after that, they sure will magnetize the iron core. Okay, when they just magnetize the iron core, after that, they got cutting magnetic flux. After they cutting the magnetic flux, they produce what? Secondary induced current. Then finally, the bulb can be light up. So this one's a process. At least for 4 process you need to explain. Okay, we're going to see the first one. Alternating current. You must mention in. When it just in is what current? Alternating current. Flow in the primary coil. Then the alternating current is what? Various magnitude and direction current produced. Okay, so the alternating current is the various differences magnitude and also the direction. Okay, after that magnetize, they will cutting the flux. Okay, changing magnetic flux will be occur. Okay, changing magnetic flux. Okay, then number 3, the changing magnetic flux cut through the secondary coil. Okay, changing magnetic flux, they cut until go to the secondary coil. So finally, number 4, the alternating induced EMF is produced in the secondary coil. So this one is a 4 process. How to make until the secondary circuit can get the current. Okay, so the secondary they get the current also is an alternating current. Okay, normally they just mention induced EMF. They never mention induced current in the secondary coil. They say induced EMF. Okay, so important this one, when I just ask about how the transformer working. Okay, then we do calculations. Okay, the current flow in the secondary coil. They want to ask about the current. So the current in the secondary coil, we just see the part for the output lah. Okay, we got power, we got volt, so that means no problem lah. You find the current. Okay, so from here, info, power output 24, voltage 12. Then they give you the efficiency is a 90. Then the first question they ask you about the secondary current is how many. So we're just using P equal VI. P equal VI, we can find anything already. So from here, P equal VI, but this one P is for the output. So power is 24, Vs is a 12. So I find it, the current for secondary coil, there's a 2 ampere. Okay, 2 ampere. Okay, power input in the primary coil. If they ask about power input, so you can using VI also can do. But now the problem, you do know the current input. Okay, you do know current input. You also do know voltage input. How to do the calculation? So we cannot using the formula. We just can using efficiency to find the answer. So efficiency, the formula like this. So you know the output, but you don't know the input. So we just put in. Okay, this 100, I just move to another side. They become divide. So become 0.9. So 24 is the output. Then input, I don't know. Final answer, the input, 26.67. When you find the input less than 24, that means you're wrong already. The input must more than 24 because you are 90%. You're not 100%. 100% means exactly 24. Okay, so the answer cannot more than 24 for your input power. This one should be the last one, essay. So from here, they show you 4 different of the generator, the electric motor. Okay, because they got current, there's a motor. So from here, we see what's the differences for the 4 diagram. First one, steel core. Okay, some using soft iron core. Okay, the next one, you see the number of turn. This one got double of the coin. Okay, double of the coin. This one only single coin. Okay, single coin means you're using the number of turn less lah. Double coin, that means you're using the number of turn is a more. Okay, the next one, you see the dry cell. Okay, dry cell, this one is a more dry cell. Z and also the Y. Dry cell is double. This one, WX, only 1. Okay, the next one, you see the magnet pattern. This one, magnet is a flat. W is a flat. X1 is a curve. This one is a curved magnet. Okay, so from here, at least got 4 things you need to explain. Okay, 4 things explained already is 8 marks. Then another one you need to choose. Choose which one is the most suitable. And the last one, you repeat all the characteristics and you get 10 marks. Okay, remember, we need to explain first before go to choose. Do straightforward, go to choose. So remember, prepare table form. Okay, the question already provided specification, so you just follow here. They ask about the shape of magnet, type of the coil, then the number of turn, number of the dry cell. So we start with the shape of the magnet. We need the curve one. So we just answer. Okay, table form, characteristic, reason. Curve, surface magnet. Okay, copy from the question. Shape of the magnet, is it curve? Magnet also can. Don't just curve. I don't know what curve. You must answer the question. Curve produce a rather magnetic field. Okay, type of the core. We're using soft iron core. Okay, yeah, when you just answer, you can say soft iron core. You can say soft iron core is used. Okay, reason that everybody know, easy to magnetize and demagnetize. Number of turn of the coin, we need more. Okay, don't mention you want double or single. Just say more enough. More number of turn of coin increase the rate of cutting magnetic flux. You can see when I put this one, the answer is sure another one. So they're just like the partner. Okay, when you do more, that means you understand already. When I put this one, characteristic, what is the reason? Reason already is a fixed one. Okay, when I say curve, this one sure is a reason. Rather, magnetic field. When I say soft iron, then you must know the answer must be easy magnetized and demagnetized. Okay, and the last one, dry cell. When I say dry cell, more means what? More current to flow. If I say magnet, okay, the magnet are using large magnet, increase the strength of the magnetic field. So that means the pattern already is there. Okay, then the concept is there. That means they come out, the question is almost like this. Okay, so this one is how you go to answer the essay question. Okay, if I'm not mistaken, for your coming exam, sure got one essay question. Okay, the essay question, we got two types. Either like this, let you to choose. Either is don't have anything let you to choose. They just show you the aspect. Okay, you need to explain all. That one, at least got 5 aspects you need to explain. Okay, if the question got let you to choose one, that means you no need explain 5 aspects, only 4 aspects, because you need to choose. Choose also need the marks. Okay, so which one is not related? We just go to cancel. Okay, so I want curve. Then the flat one, I go to cancel lah. I don't want the flat one. Okay, then some more, continue. Soft iron, that means the steel I don't want. Okay, steel I don't want. Okay, next one, I want the more number of the coin. Okay, so this one I don't want. Okay, and the last one, number of the dry cell, I want more. So this one I don't want, this one I don't want. So you see which one is totally never crossed, there's a Z. Z is totally perfect one. So I need to choose. So that means this one is how we go to answer the essay question. Okay, when starting, you got thinking. You must think first. Don't start straightforward and do. You must think which one you want first, then you baru explain. Okay, later I just get you, you never read, you straight go to answer, then suddenly, I want to choose one, don't have here. How? Cannot. So you must follow the question also. After that, you need to explain for every reason. Baru you see, which one is the most suitable. Okay, this one is a technique how to do the essay question. Okay, so after that, the last one, don't forget, you need to mention again what you need to choose. So Z is chosen. Okay, so Z is chosen, that means already is 1 mark lah. Okay, because curve surface magnet, repeat all characteristic. Reason no need to mention already, only characteristic. Use soft iron core. More number of turn of coin and more number of dry cell. Then finish. Okay, this characteristic and reason already 8 marks. Then after that, Z is chosen is another marks. Then this one repeated is another marks. So that means the chosen and repeat almost is together lah. If you choose wrong, that means you repeat also wrong. Okay, so this one is what you need to know how to do for the essay question. So from here should be finished. Okay, our lesson just until here about chapter 4. Okay, everyone, bye.